Okay, I think that we can start. We can start with the event, uh, and let's start with the presentation. So, as you already know, usually the events are hosted by us, Andres and Ingus. Andres is co-CEO and more sales related and more partnerships related, and he started off at Mapon something like 11 years ago. And I'm Ingus. I'm more technical, also holding the co-CEO position, and I get into the communication and details once we get very technical. So yeah, uh, on other events we also have some other hosts who are presenting. This time we are just two of us, and we have set up a basic schedule for the events for the first couple of months, and due to the fact that some of the events that we have planned are not ready from the product perspective, we just chose that we will start the year with the fuel, just because that's a very I would say important topic, and we have been in this full fuel control business for ages, and I think it's a good idea to share the experience and probably provide some insights on what's happening in the industry, and what are the things to keep in mind when you are providing the fuel control solutions to the customers. Yeah, and basically the agenda for today is explaining like what is the reason why we should track fuel, a bit of physics behind the fuel, also the types of measurement on how you can measure the fuel and what are the measurement like pros and cons. Also, we'll talk a bit about sensors and calibration. And also, I will just briefly touch the subject of alternative fuel types like electricity, LPG, LNG, CNG, and all of the rest of the stuff. And also, I will take a very brief look at the fuel-related features in the Mapon platform. And as usual, we'll have the questions and answers section at the end of the meeting. So let's start with the biggest question on why we should track the fuel, and basically I would say there are two very straightforward reasons, and one is eliminate theft, and the other one is automating reporting. And if we're talking about eliminating theft, then we're talking about various strategies on how to steal the fuel and things like that, and these are huge costs for the companies that are affected. And if we're talking about the report automation, then it's getting the reports for the accounting, getting the reports for the government in some countries, and also it provides information to plan for the future, like costs of transport and things like that. So if we're getting closer to the theft situation, then I think that it's so this is basically how it happens. I mean, like it's the most popular way of stealing fuel, just getting next to the truck, putting up in the fuel pipe, getting the barrel or some other thing where you can put in the fuel, and just sucking out the fuel of the fuel tank. And this one is like a straightforward. There is no tricks involved, just basic physics that you can pump the fuel out and that's it. But we have seen in our experience that even after installing separate fuel sensors, the drivers are doing some magic with inserting balloons in the fuel tank in order to push out the fuel and trick the fuel sensors. There are some tricks where they're using the vehicle air suspension system, where they get the vehicle up to some specific angle just to keep the same level, and then pump the fuel out. And yeah, that I would say that's the most popular way. Another way, which is also very popular, is actually not filling the fuel in the fuel tank at all. I mean, like it means that you go to the fuel station, you put some of the fuel inside the vehicle and some fuel in the fuel tank or some other vehicle, and we will get to some extreme cases in this scenario as well. And the third one is actually the most advanced one, which means that the drivers are sometimes connecting to the fuel system between the fuel tank and the engine, and then dripping the fuel into some barrel or something again. And if we're looking at some of the extreme cases that we have seen in our experience, then I would say the most extreme case with not filling the fuel in the fuel tank is connected with the fishing boat that we had here in Latvia. And according to the captain, the fuel consumption was around 50 liters per hour, and the owner was constantly providing that amount of fuel, and unfortunately not all of the fuel was actually put in the ship. And as soon as we installed the fuel tracking system with the fuel sensor, the actual consumption went down to 25 to 35 liters based on the weather conditions in the sea and things like that. So it basically means that they were saving something like 20 liters per hour, and if we're taking into account that each trip to the sea is around, in this case, something like 10 hours, then they are basically saving a full barrel of 200 liters of fuel per one trip. And if we take into account that that this is like I wouldn't say that the ship is going into the sea each and every day, but let's say it's going 20 days a month, then we're talking about 4 tons of fuel saved per month per ship, and this is a huge amount of money. I mean, like if we're calculating just like €1 per liter, then it could be something like 4,000 euros per this one ship. And yeah, the same things we can see over and over again. And as soon as we install the fuel sensors or some other control solution, the fuel consumptions are usually going down pretty significantly. If we are talking about pumping out the fuel of the fuel tank, we also have a very good example that we had in the company that is doing peat extraction in the countryside. Like the tractor that was working there was left unattended overnight inside the field, and basically what we can see here that from May till October, it's something like 5 months. Total amount of fuel put in the tractor was something like 13 tons, and then after 5 months, checking the graphs, the total number of liters that were pumped out is something like 5,000 liters, which means that again it's something like 40% of the fuel is being stolen and not really used for the actual work that the tractor needs to be doing. And this is an extreme case, and we don't see that type of numbers too often, but that's definitely something that is a good example to give you an idea of the potential scale of the problem. And I don't have the numbers in this case, but this is how the fuel dripping looks like. Like we have this road construction equipment. We have some, I don't know, hole in the in the floor of the vehicle. There is definitely some fuel pipes going on, and what we see here is that I don't know whether the driver or the technician or somebody has connected some additional pipes to the fuel system, and is having a crane that you can open and just drip the fuel inside the cabin, and you can easily work and all of the systems that are reporting the fuel are actually like providing data that the consumption is just a bit higher, and we have also seen cases like these like lots of cases. And I would say that this one is the hardest one to like discover, just because usually either the fuel is not going into the fuel tank, either it's going out of the fuel tank more than needed, and you can easily check that by the fuel level sensors or something. But in this case, even if you put the fuel level sensor in the fuel tank, you still don't see the numbers matching there. Yeah, one of the ideas on how we solve this issue is actually sealing some of the places in the fuel system by coloring them. And if you do that, then potentially if somebody is trying to open the fuel system and trying to connect something additionally, then you will see that some of the connections are not colored or are broken or something. And this is just one of the strategies that can be used in some very industrial cases. Like in this case, in the pictures, you see this first ship that I was talking about, that it has a pretty complex fuel system. And then after installing the fuel sensors, we actually understood that it's important to seal all of those places where you can connect to the fuel system in between the engine and the fuel tank. So yeah, the idea of eliminating theft is actually there are various ways on doing that. Like each and every vehicle has some onboard sensors, and one of the easiest ways is just connecting to the CAN lines of the vehicles. Of course, there are vehicles where you cannot install additional fuel sensors, for example, like light vehicles, light commercial vehicles, minibuses. It's hard to do any additional installations, and in these cases, we totally believe it's a good idea to rely on CAN data and keep that as the source of the data. In cases when there is an option to install additional fuel sensors and it makes sense, then we totally recommend also installing additional fuel sensors. And there are also customers which are combining the strategy in eliminating the theft. For example, they are using the onboard sensors and driver behavior solution in combination, and they also provide some bonuses for the drivers for driving under some certain limit of fuel consumption. And in case they are driving with less fuel, they're actually getting some part of the saved fuel in monetary reward for good driving. So I would say that even if you don't have any sensor connections, be it onboard sensors or additional sensors, it could be the case that implementing just the driver behavior solution is also a good way on how to save fuel. But if you are talking about eliminating theft, then it could be the case that it's a bit too few for eliminating the theft, just because he can drive as good as possible, but if he is pumping out the fuel, you will not see it without the sensors. And of course, one of the ways is also relying on the accounting data for the fuel checks and fuel bills. So yeah, we'll get to that a bit later on as well. I'd like to also talk about a bit of about the physics and why it's important in this case. And we all know that there is some thermal expansion ratio for various types of material, and in this case, we looked up what's this ratio for the diesel fuel, and in this case, you can see that it's 0.00095% per degree Celsius, which means that if you have a fuel tank of 500 liters, and the temperature of the fuel tank changes by 10 degrees, then basically there's a 5-liter change in the volume. And if we're talking about the light vehicles, then I would say the fuel tank sizes are so small that it's not important at all. If we're talking about the trucks, then it could be getting interesting, just because in cases where you have a fuel tank of 700 liters and the temperature can change for something like 20 degrees, then it's hard to distinguish whether the change in volume is because of the temperature changes, or is it something like 10-liter fuel theft or something. And the physics is getting more important if we're talking about bigger capacity fuel tanks. And we also have experience in installing fuel sensors in these types of barrels of fuel. And this is where it gets complicated, just because of the impact of the huge volumes. And we have failed quite a few times, and are not really actually entering into this market again, just because there's a like very big risk of not providing quality data for the customers. But still, there are some cases when the customers understand that they will not get decent information for 100-liter fuel theft or something, and they are still ready just to eliminate those cases when somebody is stealing 500 liters or 1,000 liters. But yes, this is if you're talking about these sizes of the fuel tanks, then definitely physics is coming into play, and you should be doing some calculations on what precision can you actually offer for these types of tanks. Then let's get to the measurement part, and this is the interesting part on how you can actually measure the fuel amount of the fuel. And in this case, one of the easiest ways is measuring the fuel level, which means that there is some sensor that is giving us an idea of like what is the fuel level in the fuel tank. Then we need to know what is the fuel tank capacity. Then we can calculate what's the number of liters inside that fuel tank. And it doesn't matter whether it's a float in the fuel tank, whether it's a fuel level sensor, either capacitive or ultrasound. All the sensor gives is some idea of like what is the level of fuel inside the fuel tank. And when we're talking about the levels, it's important to note that there are some certain dead zones in the fuel tanks that the sensors cannot see. And if you're talking about the built-in sensors that all of the vehicles have, most likely the dead zones are something like we can see on the screen currently. And if we're installing additional fuel sensors, then probably we can reduce the dead zones and get those dead zones a bit more to the top and more to the bottom, but still you cannot eliminate them at all. So you have to keep in mind that there could be a case that the fuel tank is so full that the sensor cannot give you information about how actually full it is, and then the driver can easily at some moment just take out the fuel that's in the dead zone. And the same applies to the bottom of the tank. And the other option on how to measure fuel is actually how we are used to measure fuel in the fuel tanks. It's fuel flow, and there are also two options. Either it's a fuel flow meter that's inside the engine, and it's like mathematically calculated by the vehicle itself, and then provided to the engine control unit, and also we can read it out by tracking devices. And the other option is to install additional aftermarket fuel flow meters, and this is the scheme that on how it potentially looks like. And according to our experience, I would say that we are installing very few of those fuel flow meters as aftermarket solutions, just because we have seen pretty bad performance in terms of what happens to the vehicle power and things like that, just because each of those things that you add on top of the fuel lines, it reduces the fuel throughput, and it means that the engine can potentially receive less fuel than necessary, which means that that you're reducing the engine power, and then probably at some point the customer is complaining that, hey, as soon as you install this fuel control system, the employees are complaining that they are not powerful enough to do the job they are meant for. And also, if we're talking about this type of aftermarket fuel control solutions, then you have to keep in mind that it could be a lot more tricky in terms of warranty, just because you are also being intrusive into the fuel supply system for the engine, and this is pretty tricky. If we're talking about the fuel level meters, then it could be the case that the warranty is applying only to the fuel tank, and in case of ultrasound level meters, the warranty is not affected in any way at all. So yeah, another thing from the physics point of view is also the fact that there could be some angles and shapes of measurement. I mean, like when the vehicle is driving uphill, when the vehicle is driving downhill, if it's standing on some I don't know how to call it, but like a steep angle, then the measurement can be off of what it really is. But then in the fuel graphs, in the fuel section, we can easily see whether the fuel level is returning back to the normal or not, and that's the analysis part on the platform. But in this case, the picture shows the reason why it's important to install the fuel sensor in the middle of the tank and not at one end or the other end. I mean, like if we would be installing the fuel sensor at one or the other end of the fuel tank, then the fluctuations between the once the vehicle is put into some angle, then it could be the case that the readings are way off from the actual values. And we have also seen some competitors in Latvia installing two fuel level sensors, but we don't really believe that it's necessary to do that, at least according to our experience. And if we're talking about the shapes of fuel tanks, it completely depends on the vehicle, on what kind of shape is the fuel tank and due to this, it's very important to talk also about the topic of calibration, which means that we're pumping out all of the fuel from the fuel tank, then we are putting back the fuel in some doses, and then we are getting the readings from the fuel level sensor on what reading does the amount match to, and then we can be pretty precise on the fuel level, no matter what is the shape of the fuel tank. And we have seen that this is something that is a challenge. I mean, like if you don't have the proper tools for doing the calibration, then it means that you will spend lots of time for doing the calibration. And in this case, I have a small video from one of our technicians that just demonstrates the idea of what's happening. I will just start the video and try to talk over the video. So basically what we can see here is a fuel tank. We are taking the fuel from one fuel tank. We have the sensor installed, and then we have the fuel pump in the bus, which is pumping over the fuel from one tank to the other one. The pump starts working, and the fuel is being pumped into the other tank. Also, we have the fuel sensor installed, and we have the fuel sensor connected to the PC inside the van, and then we also have some automated calibration process under the hood. So basically, we calibrate the fuel sensors with the 30 liter doses, and all of the process for us is completely automated. As soon as the numbers reach 30 liters pumped over to the other fuel tank, then the pump is stopping, and we get the reading for a couple of seconds, or 30 seconds or something, till it stabilizes, and then we just continue the calibration with the next dose of 30 liters. So it means that in our case, we are not doing that manually. We have completely automated the setup, and the technician just has to like install the wiring and things like that. But he doesn't have to take the fuel with his hands or something, or he doesn't have to go to the fuel station and things like that. Yeah, in this case, we just wait for the stabilization, and as soon as the values are stable enough, then the next process of calibration is starting. So in this case, we are waiting 30 seconds for the calibration data from the fuel sensors to be stable. And as soon as that is done, the fuel pump is starting to work again, and also doing the next calibration for the next point. So yeah, if you are interested in more in this technical solution, then probably it's a good idea to contact us for more detail, and then we can provide some information on how does that happen and things like that. I will just switch over to the next slide. So yeah, one of the things that you also saw in this video is the fact that some of the vehicles have multiple fuel tanks, and the fuel is flowing from one tank to the other one, and basically it could be the case that if you are looking at just one fuel tank, you don't see the full volume of the fuel tank, and also if you're looking at the first tank, then you can see that this fuel level is being reduced at the very steep edge on the start, and for the other tank, the fuel is slowly being added to this tank, and then in this case, it's important to look that if the vehicle has multiple fuel tanks, then it's important to look at the total line for understanding what's actually happening. Like in one case, it could be the case that it looks like it's a fuel theft if the sensor is installed in just one fuel tank. And I'm not really sure, but I guess that some of the vehicles that have multiple fuel tanks have onboard sensors only on one of the fuel tanks, which could be pretty tricky if you are trying to control fuel. Yeah, and if we're talking about challenges, then multiple fuel tanks are pretty big of a challenge, and one of the reasons is that the devices that have RS-232 connections most likely cannot support more than a couple of fuel sensors, but we have seen trucks and buses and cranes which are having like 6 and 8 fuel tanks, and also the ships that we installed the fuel control system have been with something like 8 fuel tanks or something. And in these cases, you have to keep in mind that you have to look for specific devices for that that have RS-485 connections, or you can also look into these wireless fuel sensors, which are working on Bluetooth low energy protocol. And also, there are some specific cases where it's impossible to do the wiring, and we can see in this picture some of the like forest equipment, which is rotating 360 degrees around the axle, or how do you call it? And in this case, you cannot install the wired fuel sensors and connect them to the unit in the cabin. So there are two options: either you install the wireless fuel sensor, either you have to do some very interesting tricks with the installation. So yeah, in this case, I would say that it's important to understand like what is the unit actually capable of, and what are the wiring implications for the unit. And we also tested the wireless sensors, and we feel that it's important to know this, that there are cases when it's important to use them, like this case. But from our experience, we're not really open for replacing all of the wired installations with the wireless ones, just because using wireless fuel sensors introduces lots of interesting challenges. For example, you have to keep track of the battery when the battery runs out, and things like that, which is additional load on supporting the solutions. Where using the wired sensors, okay, it makes the installation a bit more complex, just because you have to pull the wires, but you can totally save it afterwards on checking when the battery will run out, and things like that, and returning to the vehicle after, I don't know, 3 years or 5 years, whatever the battery will last. And yeah, from our experience, we're pretty cautious about the wireless fuel sensors at this stage. But yeah, we are using them in specific cases when it makes sense. Yeah, we're slowly coming to the end part. Alternative fuel types. We have also done some pilot projects here in Latvia with trying to connect to the vehicle onboard computers for retrieving CNG data, LPG data, and things like that. We have some customers who are actively using these types of vehicles. We have also seen some interest from the vehicles from companies having electric vehicles, and there are some interesting developments. And just recently, we have updated Mapon platform and added lots of different fuel types. So I will just in a moment will try to show that in the Mapon platform, and how does that affect. But the interesting thing is that it's totally different on how you measure the units. I mean, like if you're used to tracking fuel in liters, then CNG is tracked in kilograms and things like that, which is a bit tricky to wrap your head around, and the same applies to electric vehicles. So yeah, but I will just in a moment we'll try to show some of the features in the Mapon platform as well. And then yeah, to summarize, there are lots of fuel related platform features in the Mapon platform, like the settings section, where you can set up the fuel settings. I'll just try to quickly switch over to the settings. Hold on a second. If we're talking about the fleet, then this is our installations team fleet, and there's technical information where you can set up the fuel type, whether it's diesel, whether it's petrol, and all of the rest of the types. And if we're talking about the fuel level and fuel level measurements, then it's important to always enter the fuel tank capacity, which will let the system understand what is the fuel level in the fuel tank in terms of liters. Yeah, what else did we have here? The fuel section. Those of you who are using actively the fuel section already know about that, but the basic thing is that you can see all of the vehicles with the data on when it was filled up. You can also see the graphs on the consumption. You can also check where the location was of the fuel up, and things like that. Like in this case, I probably didn't really get to the right position, but in this case, we can see that this is the fuel tank where the vehicle was filled up, and you can easily check also the fuel drains. And we have also seen cases where the customers are actively using this fuel chart and checking the fuel drain locations, and then they notice that once a week this specific vehicle is having a fuel drain, and it always happens in some specific location in the forest, in the parking place. and then after a week they go to the specific location and just wait for the driver, and they can easily film around the same video that I was showing at the start of the presentation. I mean, like it's pretty straightforward to use this data just to check where and what happened, and then when you're talking about with the driver about fuel theft, and you're asking him, "Are you stealing fuel?" He will 100% tell that, "No, I'm not." And when you will ask, "Hey, why did in this specific location at that specific time the fuel level in the fuel tank was getting less for something like 20 or 30 liters or 100 liters," then he will have to think on whether he is open for lying or not, just because you have the facts at hand. Yeah, so the fuel section is a great tool just to check on where did things happen, and you can double check where the fuel was filled. I know that in European countries is not as important, but in some cases, trucks going into Russia or Belarus or something, it could be the case that the company has a policy on which fuel stations you are allowed to fill the fuel in, just because some of the fuel stations are not providing quality fuel. And then this is a tool on how you can check whether the driver filled the fuel in the right fuel tank or not. Yeah, fuel section. Then also we have, I don't, yeah, then we also have this dashboards where you can have, hopefully we have this fuel. Also, you can see the KPIs regarding the fuel, like what volume is used, what volume is consumed, or what is the trend, whether it's upwards going, whether it's downwards going. About the consumption, the same thing. We can see that in our case, we have reduced the fuel consumption by distance by something like 10% lately, and things like that. And that's also an important thing. That you can check easily. If you have a huge fleet, then you can get the top 5 vehicles with the biggest consumption, and then just act on them. Just talk to the drivers and ask what's the deal, and check whether it's valid or it's not really needed. There is some part that I'm not really that confident about. Probably this is something that you will have to talk to our sales guys and things like that. But we do have also in the fuel section option to work with the fuel bills, import. Either enter the data in the system, either upload the fuel bill from the file, and also we have the integration with the fuel cards where you can automatically get data connected with the fuel tanks, and then the fuel fills are not really measured from the sensors of the vehicle, but they are taken from the integration, and you can always be 100% sure that all of the costs that are in the fuel tank are also in the Mapon system. Also, we have quite a few reports where you can get. I think this one is also having fuel consumption. Yes, you can just easily add the fuel consumption to the routes report, and then you can see what was the fuel consumption for these specific routes. Then the driver behavior also, I would say, very important part, where you can see scores based on fuel consumption and things like that. Also can order the vehicles by the fuel consumption and check whether the scores that you have here can also be connected with the fuel consumption. And finally, last but not least, I would say that it's important to note that we can also have lots of information exposed via the Mapon API, which means that the customers can get signals that the fuel is stolen or something, and then can act on them. For example, in this case, I think this is the request that you can check what was the fuel change. I mean, like 275 liters are pumped out of the fuel tank. You also get the location, they also get the time, which means that they can very quickly introduce automated processes that keep track of the fuel. And I know that some of the customers are also using some SMS notifications for the drivers in case the fuel is lost in the fuel tank. And it could be the case that the driver is standing in the parking lot and somebody is pumping out his fuel, and probably at some point we can react as soon as that's being done, and the driver can still stop it. And also there are some cases when the trucks are returning to the base, and then they pump the fuel out in the base and do things like that, and then you can just ignore some of the events that are happening in controlled territories and things like that. And also, if we're talking about accounting, then using API for accounting is also a good thing, just because then you can easily keep track of the remaining inventory that you have in the vehicle. So like we have this rule in Latvia that you have to keep track of all of the fuel that is on the specific date in the fuel tanks of the vehicles, and then you can use API just to check on what is the remaining value of the fuel. And finally, just to summarize before we get to the questions and answers, and I'll just quickly return to this part, which is like the tricks with the fuel theft, or actually this one, eliminating theft. Installing the fuel sensors, or installing devices and connecting to the CAN lines is actually not the only, like it will not magically eliminate the theft, and you will have to educate the customers that you have to make use of the system that you have. I mean, like, you have to proactively check in the system what is the consumption, talk to the drivers, and let the drivers know that they are being controlled. We have seen a number of cases where we install the fuel sensors, the company owners or the managers are not doing any action on the data, and after a couple of months they are telling to us that, hey, your system is not working. And when we go to the site, we do the test fuel theft on their site. Everything is working, and then they do the test themselves, and they also understand that it's working. And the fact is that, due to the fact that they didn't implement any process of actively checking the data and talking to the drivers and bringing the facts to their attention, the drivers have been continuing to steal the fuel at the same rate as it was previously. So our recommendation is definitely talk to the companies and tell that you have to proactively look into the data and act on that. If you're not doing that, then you're just wasting time and money on the fuel control system installation. So yeah, I would say that's basically it from my side. Okay. I hope you enjoyed. I hope you enjoyed the event. At least I enjoyed talking about the stuff. I also enjoyed the video with the guy pumping out the fuel. And the funny part is that I was putting the video in the presentation, and then Andres saw the presentation, and he told me that he actually knows the guy. Which is like an interesting moment in this case, that the world is so small that even so funny videos can be traced back to somebody you know.
Just to clarify, he is actually not a thief, yeah? It's all good.
You can definitely tell that by the video and things like that. Okay,
right, yeah.
I guess we can end the event here and see you on the next event, and let's talk about the Bluetooth features that we have built in the platform. See you next time. Thank you.